Hi everyone, today we're going over chapter 3.1. So we're going to talk about a relation, a function, domain, and range. All right, so function, a relation. A relation is any set of ordered pairs. So a relation is any set of ordered pairs. So what is an ordered pair? Remember, an ordered pair is like x comma y. So for an example, 3 comma 2 is an ordered pair. And when you have a set of those, that is called a relation. So for an example, this is an example of a relation. See how it's just a bunch of ordered pairs? And this is the fancy set notation. These little squiggly, they're like almost like parentheses, but it's a different kind of parentheses. This is set notation. And so we have a bunch of different ordered pairs. So this is a relation. T-tables is an example of ordered pairs. So sometimes you'll see the T-table written sideways. I don't really like the sideways horizontal view. I like the vertical view better. So this one's my favorite because you can see the ordered pairs easily. So here you can see the ordered pair. So this ordered pair is -6 comma 3. So, and then this ordered pair is 4.3 comma 2, comma 2/3. So I like the T-table going up and down. It just makes more sense to me. But a lot of times in textbooks, they will go straight across simply because it saves space. So it saves a lot of space in a textbook. So they'll do it across. But I like the T-tables going up and down. So this is an example. So T-tables are example of a relation. Then we have this thing called mapping notation. That's a relation. So this just basically means zeros being mapped to -3. So zeros going into the machine, -3 is coming out of the machine. Here you've got 1 going into the machine and zeros coming out of the machine. Here you have 2 going into the machine and you have 2 coming out. And then you also have 2 going back into the machine and then 3 is coming out. So notice the number 2 is being mapped, it has 2 different outputs. So you have the same input having 2 different outputs, right? And then the last one, 3 is going into the machine and 1 is coming out. So it's just a different style. Mapping notation, we don't see that often, but it's another style of writing a set of ordered pairs. Notice here you have a set of ordered pairs, so all of your graphs are relations. So this is a relation because the definition is a set of ordered pairs. This parabola is a U-shaped. It's called a parabola. This is made up of infinitely many ordered pairs. So remember, graphs are made up of points, which are called ordered pairs. So this is also a relation. So all of these are just examples of a relation. So once again, these are just all examples of a relation. Just different styles. Set notation, T-table notation, graph notation, mapping notation are all examples of a relation, which is a set of ordered pairs. And then we have the word function. What is a function? A function is a special kind of relation. So where you have a bunch of ordered pairs is a relation. Well, a relation that has a special circumstances is a function. So let's see, what is a function? To be a function, all of the inputs, which are your x values, so remember your inputs are your x values. So your inputs are your x values. Your x values or your inputs have to have exactly one output, and your output are your y values. So your inputs are your x values and your outputs are your y values. In other words, each x value can only be paired with exactly one y value. If that happens, then you can say it's a function. So let's look at these examples. Let me blow them up. So let's look at example 1. Is that relation a function? So we have to look at the x values and see what's happening with them. So notice here you have -3 is going into the machine. So if you think of it as a machine, and -3 is what's going into the machine and 4 is coming out. Now you have the same machine, but now you have -8 going into the machine and you have 5 coming out. So you have what's going into the machine and what's coming out. Your X is what's going in and your Y is what's coming out. And then you have 7 going into the machine and 0 coming out. And then notice that -8 is going back into the machine. So here we have -8 going into the machine and we have 5 coming out. And then later on, we have -8 going back into the machine, but we have a different number coming out. So notice that -8, so -8 is going into the machine, and then 5 is coming out. That's what this one says. And then -8 is going back in the machine, and then 2 is coming out. So you can't have the same input. Sorry, you can't have the same input having different outputs. So let me clean that up. So I cleaned it up a little bit and showed you. So here you have -8 is the X value and it's being paired with 5. And then you got -8 again paired with 2. So that is not a function. So this one is not a function. So if we go back and read it, it says, in other words, each X value can only be paired with exactly one Y value. And here we've got -8 being paired to 5, and we have -8 being paired to 2, and that's a broken machine. You can't have -8 going into the machine, and then you get a 5 coming out, and then you put -8 back into the machine, and then you have a 2 coming out. You can't have the same number going in and having 2 different numbers coming out. That is a broken machine. That is not a function. So this one is not a function. Let's look at example number 2. Example number 2 is using mapping notation. So for the relation to be a function, you have to make sure that each X value is only paired to one Y value. And notice here that 0 is being paired to -3, 1 is being paired to 0, and then 2 is being paired to 3, and then it's also being paired to 2. So you have the same number going into the machine being paired with 2 different outputs. So remember, the X they're the inputs and Y's are the outputs. You can't have the same X value or the same input having 2 different numbers come out or have 2 different Y values. So this is not a function. Because 2 is paired with multiple Y values. So this is not a function. Let's look at example number 3. Let's see if any X value is paired with multiple Y values. So here you've got -6 is paired with 3. You've got 0 is paired with 0. You've got 5 is paired with -2. And you've got 4.3 is paired with 2/3. Notice we have all different X values. Notice, right? You don't have a repeating X value, so this is a function because each X value is paired with only one Y value. So this is a function because each X value is paired with, that's a little with sign, only one Y value. So again, see here how the 2 is being paired with 2 different X values? That's a broken machine. That's not a function. Do you see how -8 is being paired with the 5 and the 2? So that's not a function. Okay, so now let's go over domain and range. Domain describes the X values. So the domain are really the X values, which are also called the inputs, which are also called the independent variables. The range are the Y values, which are also known as the outputs, which are also the dependent variables. So what's coming out of the machine are the Y values. and that's the range. So the y values are what comes out of the machine, and that is known as the range. What's going into the machine are the x values, and those are called inputs, and that's the domain. So the domain are the x values which go into the machine, and the y values are the outputs, and that's what's coming out of the machine, and that's called the range. So basically, and then we have independent variable and dependent variable. So for an example, if I go to Costco to get gas, the cost depends upon how many gallons of gas I get. So we would say the range would be, or the dependent variable would be the cost, and then how many gallons would be the independent variable, because how much it costs depends upon how many gallons of gas I get. So we'll get into that later. So basically just showing you again that the range are the y values, right? The range is the outputs, which are the dependent variable, which are the y values, and the domain are the input values, which is the independent variable, which are the x values. And again, we're just showing you again that the domain are the x values and the range are the y values. So in problem number, example 1, 2, and 3, it says find the domain and range of the function. Hint, that means simply to identify the x values and identify the y values. So these are super, super easy. Let me blow them up. It almost feels like it's too easy. So the domain are just to identify the x values. And we like you to put the x values from smallest to largest. So notice that negative 12 is going to be the smallest number, and we like to use a little set notation and then a comma. And then out of these, so I'm looking at these numbers, let me highlight them. So these are the x values, right? The first number in an ordered pair are the x values. Right, so in an ordered pair, the x values are first and the y, it's alphabetical, y values. So we just have to put them in order. So we've got negative 3. Notice that we have 3 twice. So when we have multiple numbers, we're not going to list them twice. Because when it's asking for the domain, it's just asking what's going into the machine. So we don't really care how often numbers are going in. We just kind of want to know what kind of numbers are going into the machine. So your domain are the x values. That's what's going into the machine. So we have a negative 12 going into the machine. We have a 0 going into the machine. That's that one. And then we have our 3's going into the machine. And then we have 4.23. So we're just listing our x values and putting them from smallest to largest. For the range, we're just listing what's coming out of the machine. And the y values are your range. So that's what's coming out of the machine. And we like to list them from smallest to largest. So you have to think of a number line. So when I'm looking at this, negative 6 is definitely the smallest numbers. We're going to use the little set notation. Negative 6, comma, that's that one, check. And then we've got a negative 2/3. And then we've got a 5. And then a 7. And then a 32. So we just want to make sure that we've listed all of them. If there were duplicates, we wouldn't list them twice. That's it. Just list the domain and range. In example number 2, what is the domain? So the domain are the x values. And all you have to do is list them, and just list them from smallest to largest. So negative 6 is the smallest. To use our set, practice using your little squiggly set notation. And then 0, and then notice 4.3 should be next, and then 5. All you're doing is listing the x values. You're like, that can't be that easy. Yes, it is. That's it. Output. The range are the y values. So the range are the y values. So all you have to do is just list the y values. And we say we want you to list them from smallest to largest. So negative, do your little set notation. So let's see, negative 2 is the smallest in that list. And so negative 2 is coming out of the machine. 0 is coming out of the machine. 2/3 is coming out of the machine, and 3 is coming out of the machine. So we just listed them from smallest number to largest number. So this relation, right, set of ordered pairs is a relation. This relation is a function, and they want us to list the domain. So domain are the x values. So isn't it true that each one of these points has what's called an ordered pair, and those are called the coordinates of the ordered pair. So let's look at this point. So you guys should already know the coordinates. So this is at -3 is the x value, right? -3. And -2 is the y value. So that's this coordinate. And then this point has the coordinates -1 and then 0, right? And then this point has the coordinates +1, right? So this point moved 1 to the right, and then it is high as 2. So it's 1, 2. Be careful because some kids say 2, 1. So remember, you always say the x coordinate first and the y coordinate second. And then this point is 3, and then it went as high as 4. So all you have to do is just list the x values. So if you can do this without actually listing the coordinates, so I'm going to get rid of all this other stuff because there's all these other things in here that are getting messy. Like we assume that you guys already know how to list your ordered pairs, right? And list the coordinates. So now we're just going to list the x values. So we're going to list them from smallest to largest. We're going to use a little set notation. So -3 is the smallest number, and then -1, and then +1, and then +3. And then for the range, what's the range? Do you remember what the range is? It's the y values. Yes, the range is the y values. So now we just have to list the y values. You're like, what? That's it? Yep, that's it. We just list them in order from smallest to largest. So let's see. So on the y value, so remember on an ordered pair, the y value moves the point either up or down. It makes it higher or lower. The x value moves the point to the left or to the right. Right? So when we're looking at the y values, we want to go to the lowest point. And so this point is the lowest, and it has a y value of -2. Then this point is the next lowest, and we're working our way up higher, so that's 0. And then this point is moved up to 2. And this point is the highest, it's up to 4. And notice -2 and +2 are different. So that's listing your domain. Now the question is, can you do it without writing out the coordinates? So I erased it. Let's start all over again. So can you do it without actually writing down the coordinates? So can you just look at, when we do the domain, don't we want the x values? And so that moves the points to the left or to the right. So we want to go to the point that's furthest to the left, and then we're going to look up with our eyes, and doesn't that have a value of -3? And then this is the next point. So this point has a value of 0. And then this point, you're going to look at your eyes, has a value of 1. And then this point has a value of 3. Isn't that so much easier and so much faster? And then when we're looking at the range, we're looking at how high or how low the point goes. So we want to look at the lowest point. So the lowest point is down here at -2. And then this point is at 0. And then this point is as high as 2. And this point is as high as 4. And that can just do it a lot faster that way. So why don't you pause the video and why don't you practice doing it yourself, and then you could rewind it a little bit and see if you got it right. Let's go to the next topic. Okay, this topic is called the vertical line test. Notice that these are all relations. What's the definition of a relation again? A relation is a set of ordered pairs. A relation is a set of ordered pairs. And they can come in T tables, They can come in set notation. They can come in that weird mapping notation where it's mapped, and they can come in graphs. So these are all relations, but we want to determine which of these relations or graphs will give you a function. So which one is a function? So remember, a function is just a special type of relation where each x value is only paired with one y value. So remember, each x value is only paired with one y value. So how to tell if a graph is a function is to do what's called the vertical line test. The vertical line test is if you drop a vertical line and it hits the graph exactly only one time, then it is. So a vertical line test can only hit the graph one time for it to be a function. So notice if I drop a vertical line, it only hits the graph once there. But if I keep dropping, if I can drop any vertical line, so if I drop this vertical line, know that it's only hit once. But if I drop this vertical line, notice that it hit the graph twice. So because it hit more than one time, it is not a function. It failed the vertical line test. We'll just say vertical line test, abbreviate it because I don't want to write it all out. So that is not a function. So we can tell if a graph is a function by doing the vertical line test. So look at example number 2. Imagine yourself dropping any vertical line. No matter which vertical line I drop, it's only going to hit that line, that graph. So this is the graph we're referring to. This is called the graph, right? This is called the graph. What it's on is called graph paper, right? But this is the actual graph, and this is the actual graph. It's on graph paper, but that line is the actual graph. And notice it only hits that green line only one time. So yes, it's a function. Because it passes the vertical line test. Let's look at example number 3. What do you think? Is that a function? Yes or no? Does it pass the vertical line test or fail? How many times? If you drop a vertical line, notice if you drop a vertical line here, it only hits once. But what if you drop any other vertical line? Doesn't it hit twice? So if you can drop a vertical line and it hits more than one time, then what is it? Is or not? Correct. It's not a function. It can only hit once to be a function. So it's a function when it only hits one time. If it hits more than one time, it is not a function. So it failed the vertical line test. So it is not a function. What about example 4? Can you try it? What do you think? So if you drop a vertical line, can you ever get it to hit we call that a parabola? Can you ever get that U-shape, what we call parabola, ever to hit once? More than once? Nope, it only hit once, 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 only one time, only one time. So is it or is it not a function? And did you say yes, it's a function? Because, we'll say BC for because it passes the vertical line test. So right here, it can only hit once to be a function. So that's the vertical line test. So what did we go over today? We went over vertical line test. We went over what's the definition of a relation. A set of ordered pairs is a relation, and then certain types of relations are functions, right? Certain types of relations can be a function. And we talked about listing the domain, which are the x values, and listing the range, which are the y values. So today it's a little bit about vocabulary. So look at the notes that were posted in the module.